Hello students, in today's class we are going to talk about the Lowry Bronsted concept of acid and bases. This is also known as proton theory. Why this is called so proton theory? According to this theory, the substances which can donate H plus, proton, are called acids. The substances which can accept H plus, which can accept proton, are called bases. Very simple concept. Acids, based on this, substances which can donate H plus, otherwise proton, in their solution are called acids. And what are called bases? Bases are nothing but the substances which can accept H plus, otherwise protons, in their solution. Very simple. Yes, you will be taking this example, HCl, when it is dissolved in water, H2O, there will be a possibility of getting H plus ion and Cl minus. Now the proton is ready. The HCl will donate this proton to the H2O. As this is the donor of H plus, you can call this as an acid. So this is the acid. And which is going to accept this H plus? This water, H2O. So that I can say this is the acceptor of H plus. So that we can call this as a base. After the loss of hydrogen plus, this HCl can give Cl minus, so that is a counterpart. After accepting this H plus, H2O can form H3O plus. These two can interact with each other, so the action can be continued in the reverse direction also. So in the opposite action, you see, now this can able to donate. This will be the donor of H plus, so that we can call this as another acid. And this will be the acceptor of H plus, so that we can call this as a base, acceptor of H plus. So this is the base. Very, very simple. In the forward action, HCl is the acid. In the backward action, H3O plus is the acid. Acid is donating the H plus. Okay. Now, the acid, after the loss of H plus, is forming Cl minus, that is a base. I can take this as acid 1. From this acid 1, we are getting a base, and this base is called as base 1. Likewise, the base H2O is termed as base 2. After accepting H plus, it is forming an acid. This can be called as acid 2. So we can find the conjugates of the HCl and H2O. That is called conjugate acid base pair. So we are going to talk about the conjugate acid base pair now. Okay. The second example of Lowry Bronsted concept of acid and base. According to this, we can take H2O and NH3 combination, ammonia, which is getting dissolved in water now. Now the water is the substance which can act as a proton donor. What are all the substances which are donating the proton are termed as acid. So in this case, this is the acid. And NH3 will be the acceptor of proton. Acceptor of H plus. so that we can call this as a base. So after the donation of hydrogen plus, this is forming OH minus, and after the acceptance of hydrogen plus, this can form NH4 plus, the ammonium ion and hydroxyl ion. In the opposite action, now this is the proton provider, proton supplier, so that we can say this is the proton donor. We know that always proton donors are behaving like acids. And this will be the proton acceptor, because it can accept the hydrogen plus, so that we can call this as a base. See the combination. Acid 1, after the loss of H plus, it is forming OH minus. So OH minus is the base which is resulting from the acid 1, and hence this is taken as base 1. Now this is the base 2, after the acceptance of H plus, it is forming another acid. So this can be called as acid 2. So this is a general way of representing the conjugate acid-base pair as well as the Lowry Bronsted acid-base pairs. Yes, you just see the acid 1 plus base 2, that provides acid 2 plus base 1. They are conjugate with each other. We will try to find the meaning of conjugate acid-base pairs. Yes, how do you understand conjugate acid-base pair combination? Always the conjugate acid and conjugate base are differing by the hydrogen plus. This must be the difference in between the conjugate acid and base. So see the H2O and OH minus, they are differing by hydrogen plus, so that we can say these two are the conjugate acid-base pairs. So what would be the conjugate of H2O? The conjugate base of H2O is OH minus. Vice versa, the conjugate acid of OH minus is H2O. Likewise, these two are conjugate with each other. They are also differing by H plus. You see, NH3, when you add a H plus, you can get NH4 plus. When NH4 plus is losing a hydrogen, we will be getting NH3. So these two are also conjugate acid-base pair. Yes, we are going to explain what are called conjugate acid-base pair. Okay. Conjugate acid-base pairs can be understood as follows. We can have different examples for this case. The conjugate acid and conjugate base. Okay, so I am going to write the H2O. It is a substance after the loss of hydrogen plus. After donating the proton, it is forming OH minus. So H2O is an acid. The resulting substance OH minus is a base. These two are conjugate acid-base pairs. You see the difference in between them. These two are differing by, definitely the difference is differing by the H plus. If you want to get a conjugate base, you just remove hydrogen plus from this. If you want to get a conjugate acid for this, you just add H plus. Very simple. So acid from which one proton is transferred means we will be getting a base. The result is a conjugate base. And when you add a hydrogen plus proton to this base, the result would be the acid. It is the conjugate acid of OH minus. Likewise, we will be taking the other example, HCl. Yes, after the loss of proton, on the loss of proton, the result is Cl minus. So the conjugate base of HCl is Cl minus. When you add hydrogen plus to this, we will be getting HCl. That would be the conjugate acid of this base. So this is the conjugate acid and this would be the conjugate base. Suppose if these two are taken together, then how do you understand this concept? H2O and then HCl, they are taken together. We know that these two can interact with each other to form. After transfer of a proton to this, the result is H3O plus. So the remaining part would be the Cl minus. I can call this as an acid and this is the base. Likewise, this is the H2O accepting the hydrogen plus, so I can call this as a base. And this is the donor of H plus, so that we can call this as acid. Just identify the conjugate acid base pair now. The conjugate of HCl is Cl minus. These two are conjugate with each other. Likewise, what will be the conjugate acid of this base? These two are conjugate with each other. Very simple. The acid one, which is giving base 2, they are conjugate with each other. Base 2, which is providing the acid 1, they are conjugate with each other. So this is a conjugate acid base pair. For any example, you can easily identify the conjugate acid base which are present in that combination. Okay, we can have other example now. Other examples of conjugate acid base pair. Yes, we will be taking the sulfuric acid H2SO4. Generally it is an acid, but after providing a hydrogen plus, it can form HSO4 minus. So this can be the conjugate base of H2SO4. Very simple. Actually they are differing by H plus. In the opposite, when you add hydrogen plus to that, you can get back this acid. So for this base, this is the conjugate acid. They are differing by hydrogen plus. If I take HSO4 minus in the opposite side, why? Still it is containing the hydrogen, so it can have some acidic character. Replaceable hydrogens are there. So on the loss of this hydrogen, it can able to form SO4 2 minus. So this is the base obtained from this HSO4 minus, and this is behaving like an acid, and this is the conjugate base. When you add a hydrogen plus to this, you can get back the HSO4 minus. Is it clear? So this is the way of finding the conjugate acid base pair. The another example I am writing, NH4 plus. After the loss of hydrogen plus, after the proton transfer, it can form NH3 neutral. So for the NH4 plus, the conjugate base is NH3. When you add hydrogen plus to that, you will be getting NH4 plus. So what would be the conjugate acid of NH3? It is NH4 plus. Likewise, if you take CH3, COOH, that is giving you on the loss of H plus, it can form acetate CH3COO minus. So this is a conjugate base of this CH3COOH. Another example I am providing, H3PO4. After the loss of a hydrogen plus, it can form H2PO4 minus. The H2 PO4 minus, on the loss of a hydrogen, it can form HPO4 2 minus. HPO4 2 minus, on the loss of hydrogen plus, it can form PO4 3 minus. So the conjugate base of H3PO4 is H2PO4 minus. What would be the conjugate acid of this H2PO4 minus? It is H3PO4. Likewise, the conjugate base of H2PO4 minus is HPO4 2 minus. Why it is carrying 2 minus? The simple reason, another hydrogen is removed from that. So it has got 2 negative charges. Now HPO4 2 minus, when you remove one more hydrogen from that, we can have PO4 3 minus, phosphate. So the conjugate acid of phosphate is HPO4 2 minus. The conjugate acid of HPO4 2 minus is H2PO4 minus. So this is the way of understanding conjugate acid base pair. Is it clear?